Good day, everyone. I'm Nicole Gaylican, and today we will discuss division of line segments. The coordinates of the endpoints of a line segment are a -6, 2 and b -2, 4. If the segment is extended 3 times of its length through b, find the new endpoint b. We represent the line segment AB and the extension through b until to point P. Let the distance from A to B as d. So to represent the distance between B and P, we represent it as 3d, as it is 3 times the length of AB. To get the ratio, we need the distance of AP all over the distance of AB. So now we have 4d over d and simply cancel the d, and we have the ratio of 4. With this ratio, we can now substitute it to our formula of x equals x sub 1 plus r, quantity x sub 2 minus x sub 1, and y equals y sub 1 plus r, quantity y sub 2 minus y sub 1. For x, we have -6 plus 4 times the quantity of -2 plus 6, and we have 6 plus 16 and get 10. For y, we have 2 plus 4 times 4 minus 2, and we have 2 plus 8 or 10. So now we have the answer, that is the coordinates of P, which is 10, 10.
Good day, Ma'am Falcatan. I am Jan Arman A. Cruz from grade 10 Einstein, here to present, solve, and explain the topic given to me, which is angle between two lines, with the problem, find the interior angles of the triangle, whose vertices are M1, 2, E3, 4, and N2, 5. Then classify the triangle according to its angle. To form a triangle, I plotted the vertices on a Cartesian plane, which are M1, 2, E3, 4, and N2, 5. Okay. After drawing the triangle, we need to find the initial side and terminal side. First, let's imagine a letter X on top of the triangle and do a counterclockwise rotation. And since the counterclockwise on N ended up on line M first, this is the initial side. And lastly, it ended at line E. Therefore, initial side is NM and terminal side is NE. As for M, do a counterclockwise rotation again in order to find the initial side and terminal side. Initial side is ME and terminal side is MN. Same as for E, do a counterclockwise rotation in order to get the initial and terminal side, which is EN and EM respectively. In order to find the needed angles, firstly, we must get the slopes of NE, NM, and EM using the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Slope for NE is equal to 4 minus 5 over 3 minus 2, which equals to -1 over 1. And the slope of NE is -1. Next, the slope of NM is equal to 2 minus 5 over 1 minus 2 is equal to -3 over -1, which gives us 3, positive 3. So the slope of NM is positive 3. Lastly, the slope of EM is equal to 2 minus 4 over 1 minus 3 is equal to -2 over -2, which is equal to 1. So the slope of EM is positive 1. After getting all the slopes, we will now use the formula tan theta equals m sub 2 minus m sub 1 over 1 plus the product of m sub 1 and m sub 2. Okay, as you can see here, m sub 1 and m sub 2 are given. M sub 1 is the initial side and m sub 2 serves as the terminal side. So tan theta equals -1 minus 3 over 1 plus the product of 3 and -1 is equal to negative 4 over negative 2, which equals to 2. So theta is equal to tan negative 1 or arctan 2, which equals to 63 degrees. So angle N is 63 degrees. Next, angle E. So M sub 1 or initial side is EN, and M sub 2 or terminal side is EM. So tan theta equals 1 plus 1 over 1 plus the product of negative 1 and 1 is equal to 2 over 0, which is undefined. And in terms of angles, undefined is equal to 90 degrees. Therefore, theta is 90 degrees. Lastly is angle M. Since all triangle has interior angles that results to 180 degrees, therefore, in order to get the last angle M, we will use the solution. 180 minus quantity angle N plus angle E quantity closed is equal to 180 minus quantity 63 plus 90, which results to 153. So 180 minus 153 is 27 degrees. So angle M is 27 degrees. After solving all the triangle's interior angles, which are angle M is equal to 27 degrees, and angle E is 90 degrees, and angle N is equal to 63 degrees. Last question is to classify the triangle, and my answer for that is, it is a right triangle because a right triangle consists of two acute angles, which are 63 and 27, and thus a right angle which fits perfectly for right triangles. Therefore, the triangle is a right triangle.